So our next speaker, we have Sharon Warmerdam, who is actually one of my amazing resident advisors last summer at Cosmos over at UC Davis. And she has just graduated recently with a bachelor's in physics from UC Davis, and she plans on working towards a master's degree in education to become a high school physics teacher. Take it away, Sharon.
All right. Hello, everybody. Thank you so much for allowing me this opportunity to speak to you all. I've actually never done something like this before. As you know, I've just graduated, so I don't have too much experience, in the real world with physics. But this is a really cool experience for me, so thank you. I'm normally not a huge fan of public speaking at all, but physics is like one of my favorite topics ever, and I feel like I could just talk forever about it. So I feel like this will be fine. As Felix just said, I just recently graduated just a couple of months ago with a BS in physics at UC Davis. It was an online graduation, which was interesting. Hopefully you guys can have a real in-person graduation if you do choose to major in physics, but it was still great. It was still a great accomplishment. As he also said, I'm planning to be a high school physics teacher and get a credential and master's in education for that. But just like a disclaimer, I just have undergrad experience. So basically what my presentation is gonna be is just talking to you about like what my experience was and just certain things that I know I could have, like certain pieces of advice that I definitely could have used when I was first going into physics. So I guess I'll just start at the very beginning in high school. My favorite subject in high school is always actually math. I never took a physics course in high school. I don't know why, I don't remember why, I just never took it. So when I was deciding to choose a major for UC Davis, it wasn't even something that really crossed my mind. I was just like, well, I know I want to do something with math, and I actually wanted to kind of combine it with something creative, which I thought would be kind of hard to do. So my first thought was maybe I'll do architecture, because that's kind of combining both. You need math skills for sure, and it's like kind of a design aspect. But UC Davis didn't offer an architecture degree. I think that would be engineering or something like that. So I did go in undeclared, but I had like a loose plan to do landscape architecture maybe. And I think I just didn't know enough about it, because when I did take the class, I was incredibly bored, and it was just, it just wasn't what I expected. It was like kind of designing the environment instead of math. It wasn't very like math focused and stuff like that. But I did take an introductory physics class that first quarter as well, and it was a very huge contrast. Like, I enjoyed the physics class so much, and I was always excited to hear about like everything they talked about. It was actually called Physics of California, so it was more focused on conceptual subjects, and we talked about like applications of skiing, like kinematics of bike riding, and like surfing, just like different sports in California essentially. So it was just really cool to learn about like all those different types of applications you see around you all the time, but don't really consider how it works, or most of us maybe. But the thing that I remember the most that I connected with in that class is when we first learned about like the kinematics of how a bicycle works, because I don't know how many of you know this, but Davis is like a huge bike town, so everybody bikes everywhere. And that was the first time I actually was biking everywhere. I never biked before. But when I did learn about kinematics of bike riding, I just remember riding my bike to and from class and thinking like about the concepts we learned about angular momentum and all that stuff. And I was just like, wow, like I actually understand what's happening like as I'm riding my bike. And it was just really cool to like understand an aspect of the environment around you. So that was one of the the biggest reasons I wanted to choose to go into physics, like after that class. And there was like a secondary reason of the fact that it was like a very challenging course, which I thought was a good thing because it kind of forced me to develop better study habits. It forced me to not procrastinate, which was a huge problem. So basically then I was like, okay, I'm gonna major in physics. And so then I started, going into all the intro math and physics courses. And if you do major in physics, you're gonna have, it'll be like that. It'll be like a foundation of math, calculus, linear algebra, all those like tools that you need. Because math is like really the tool that you use when you do problem solving. And when I was first taking those courses, I realized really fast that physics was very hard for me, like compared to math. It's just like a more conceptual and problem solving focus, like big picture thinking, whereas math is like, it's like step by step, more just objectively able to get to the answer. So I did struggle more, especially in those first few physics classes. And that did cause me to ask myself, like, am I supposed to do physics? Like, should I be doing this? But like the amount of passion I had for it was kind of, it just like outweighed, even though I hated, getting C's in my classes. I was like, I know that I can work harder. So I was just like really determined. I just really wanted to learn these things because they were super interesting. So I kept on going. There were a couple of, it wasn't like a full-on straight path, as I'm sure it almost never is. So usually, you take the standard 4 years to graduate. I ended up taking 6 actually, which I think it's more common than most people think to take longer than the standard 4 years. And it's definitely okay to do that, but it's obviously not ideal because it takes a lot more money, it takes more time and stuff like that. So I'm just gonna talk about what caused that for me and sort of hopefully give you preventative advice, because they're definitely avoidable, the stuff that happened. So the first reason I got set back 1 year was simply just because I didn't talk to my advisor enough, which it's super important to talk to your advisor. It's like one of the easiest things you can do. But for me, I just thought that I could do it. Like I thought I could do it myself. And turns out there's a lot that goes into it, and there's a lot of preventable mistakes that can be made just by going to talk to your advisor. And so just definitely make sure you do that and don't just go to the required ones, which is what I did. So because of that, I got set back 1 year. And then the other one was just like, I was just going through like a rough patch personally, which that does happen a lot to people as well. And that's unavoidable. Like there's always going to be things that happen in your life that make it hard for you academically. But my advice for that would be, if you have really good like time management and stress management techniques, like early on, like especially when you first go to college, it'll really help you to get through times like that if it happens. So anyways, because of what was happening in my personal life, it caused me to fail like 1 or 2 classes. I think when I got like a D in, and the problem with that, at least at UC Davis, is that they don't offer physics classes very regularly because it's a small major. So you kind of get one chance. So that sent me back another year. But it got a lot better after that. But that's why I ended up taking 6 years. But even though I'm giving you this advice right now, it's really important, and it goes a long way to just be not too hard on yourself for this kind of thing. Like if it happens and you still want to do physics, it's like you can overcome it and you can just still do it, which like I'm living proof. So just if it does happen, just be like, okay, it happened and I'm gonna keep going. So my last couple of years of physics, the last 2 years, like 2018 to 2020, was actually like the best years that I experienced in physics, because I had just overcome a lot of those challenges that I talked about. I knew how to study physics because I just had experience with it, and I trusted that I could do it and all of those things. And so I started out like getting mostly C's in my physics classes, and then the last 2 years I've not gotten one C, and I've gotten pretty much all A's and B's, and I really understand the material now too. So I kind of want to give some tips about like how I made that successful, like those last 2 years, which hopefully you can apply to all of your years. So the first thing is to not be afraid to ask questions. This is a really big one because a lot of people are uncomfortable raising their hands in class and don't want to look like they don't know anything and stuff like that. But almost everybody is confused during a physics lecture, at least a little bit. And nobody is going to judge you because everybody else probably has similar questions, and they're probably like in their head being like, thank you for asking that. At least that was me. So, but if you are kind of uncomfortable asking questions in class, then you always have office hours available. The professors really want you to take advantage of the time they set aside for you, because they want you to succeed, they want you to do well, and so it's very welcoming to go to office hours. So I would definitely recommend to do that if you're ever struggling with anything, you need help with anything. And it's the same thing with the TAs. TAs often have even more office hours than the professors. So definitely make sure to take advantage of any type of resources like that. And another extremely useful resource is your classmates. It's like a different type of benefit because they are always available. You can always just message them or ask somebody, ask your classmate, or even just like work with classmates. It helps a lot because when you're working through a physics problem, you often encounter like a lot of different obstacles. And if you're working with someone, you can just like ask them about, like, every time you reach one, be like, oh, this doesn't make sense. Like, do you understand how this works? And it helps a lot to be working with students and getting their feedback and stuff like that. My year at UC Davis, we actually had a Facebook group chat for just like everybody who was going through the same classes, and that was so useful. I don't even know what I would do without that. Like, it was my lifeline sometimes, even for like sort of class information, like do we need a blue book for this test or something like that. So I would say try to find out if you guys have something like that if you end up majoring in physics, and then if not, you can always start one. Everybody would be really grateful to you if you did that, and then just go around and ask people if they want to join. And it also pays off to become more involved in things. We had a physics club. I wasn't actually a part of it for the most part because of I just felt like I never had time, but if you do have good time management skills, then you can definitely fit it in. And I had friends who had really good experiences with physics club, and they generally like worked on projects. They did like fun things too. Like we have this thing called picnic day at UC Davis, and they always did this thing every year where they put on a play, and it was like sort of like a popular movie or franchise, and they made it physics. Like, they did Lord of the Rings, but Lord of the Strings instead, or what was the last one? Infinity Wire instead of Infinity War, and it was actually so good. And they had a ton of fun doing it and learned things. So if you want to be involved, that is a really cool thing to do. And I know a lot of you are probably interested in undergraduate research. That's not something that I really did, because since I'm more interested in being a teacher, I didn't really need to do research, but I do have a lot of classmates who have had experience like looking for research and stuff like that. And I will say that it's a lot less intimidating to it's a lot less intimidating than you think to just like go up to a professor and just ask like, hey, do you need help in your lab? And they'll just like, the worst they can say is just I don't have room or something like that. And they might just, you know, they could just recommend you to another professor who does have room. So it's like really actually very easy to just go and ask. And I would say like, just take advantage of that fact that it's, you can just go ask them and get your research position that you want, like undergraduate research position. So I guess I'll kind of start wrapping up. I think the most important thing that I learned about learning physics is that it doesn't, it's like, it's okay if it doesn't fully come to you, like you don't understand the concepts that they're talking about like so fast, so right away, which maybe you're used to that in some other classes, but I mean, these topics are really hard. Like they're intuitively hard, and part of the process of learning physics is like doing the problem solving. Doing the problems and practicing the problems is like part of learning the concept. And like once you do a lot of practice problems, then everything will like start to fit together, and you realize that it's not like a linear system. It's like a whole, like once you learn a lot of physics, you have like this whole system of tools to help you understand the world. And it's a lot of the concepts are connected to each other in different ways, and you'll start to like make those connections in your brain. But it's just a holistic type of process, and you almost have to like trust that you'll get that understanding once you do a lot of practice problems. So don't be discouraged, and don't like think that you can't do the homework, or don't put off doing the homework because you feel like you don't understand it or something like that, because it's part of it.